Okay, see if you can figure out the formal charge for each of the atoms in this molecule using the formal charge formula. So press pause, try and work it out yourself, and when you're ready, press play. Okay, hopefully you've worked this out by yourself first. So let's go through the calculation of the formal charge of each of the atoms in this molecule. And in order to be able to do that, we need to start by knowing the number of bonding electrons for a given atom and the number of non-bonding electrons. Okay. So let's start with this oxygen first. Okay, this one on the far left. Okay, how many bonding electrons does this oxygen have? Well, it has one bond to the carbon, right? There's 2 electrons in that. Actually, I should not use semicolons here. Let's use dashes. All right, so there are two bonding electrons because it's involved in one bond with carbon. And there are a total of 3 lone pairs on the oxygen, or 6 non-bonding electrons. Okay, so what we're going to do is we're going to plug this into our formal charge formula. We're going to need the number of valence electrons in the neutral free atom of oxygen. And if you consult the periodic table, you will see that there are 6 electrons in valence electrons in neutral free oxygen. Okay, and from here we're going to subtract half the number of bonding electrons, which is going to be half times 2. So 50% of 2 is 1. And just to note, it helps that it actually gives you the same answer if you just count the number of bonds. So there's actually just one bond here. It gives you the same answer. A little shortcut helps out. Okay, and let's subtract the number of non-bonding electrons. So non-bonding electrons is 6. 6 minus 1 minus 6 is the same as 6 minus 7, which gives us an answer of minus 1. Minus 1. Okay, and usually you won't see minus 1, you'll just see minus. Okay, so charge on the oxygen is minus 1. So let's look at next, let's look at the carbon in the middle. Let's look at the carbon in the middle. So bonding electrons, well, there's 2 in each bond, so 2, 4, 6, 8. Total of 8 bonding electrons. Non-bonding electrons, well, there's none, right? It's got 8 bonding electrons in total. If it had any non-bonding electrons, then that would break the octet rule. It would be bad. We don't have any lone pairs, so that is 0. So let's figure out the formal charge using the formal charge formula. So we're going to start with the number of valence electrons in a free neutral atom. Now, for carbon, it's not 6 like it was for oxygen. It's actually just going to be 4. So 4 valence electrons in carbon. Now you're going to subtract 1/2 times the number of bonding electrons. So that's 1/2 times 4. So 4. And you're going to subtract from that the number of non-bonding electrons, which is 0. So 4 minus 4 minus 0, that actually gives you 0. So the charge on that carbon is 0. And you know, we could draw a little 0 there, but most of the time you don't bother doing that. In fact, you never ever bother drawing it. But for our purposes, it helps just to keep track that we've done this one. It's got a charge of 0. All right, let's move over to the other oxygen here. Let's look at this one on the right-hand side. You know, I'm getting a strange sense of deja vu here. So we've got 2 bonding electrons, right? 1 bond here, and 3 times 2 or 6 non-bonding electrons. Looks pretty familiar, right? Same as the one on the far left. So for oxygen, it's 6 minus 1/2 times 6 is minus 3. Beg your pardon. Went a little ahead of myself here. Minus 1/2 times 2, so that's minus 1. Minus 6. So 6 minus 1 minus 6 is equal to 6 minus 7. So that is also an answer of minus 1, but like I said, you usually just draw a negative charge. Okay, so these 2 oxygens are exactly the same. They each have a charge of minus 1. And lastly, let's look at this oxygen up here. So this oxygen here has 2 bonds, right? 2 bonds to the carbon. Each bond has 2 electrons, so 4 bonding electrons in total. There are 4 non-bonding electrons. And so we do the calculation here. We've got 6 valence electrons in free neutral oxygen, minus 1/2 times the number of bonding electrons, so 1/2 times 4 is minus 2. Number of non-bonding electrons is 4, so 6 minus 2 minus 4, again, it's 0. So the charge on that oxygen is 0. So overall, our charge is going to be minus 1, 0, 0. So overall, we've got a charge of minus 2 for this whole molecule. And the name of this might sound familiar to you. It's CO3, sometimes written CO3 2-. It's otherwise known as the carbonate ion. You may have heard of sodium carbonate or potassium carbonate. Well, this is the carbonate ion, and it has a formal charge, or it has an overall charge of minus 2, and it's because each of those oxygens has a charge of minus 1.